Okay, who am I? I'm best known for Etherpad. How many people here have heard of Etherpad? Cool, cool. How many people have used Etherpad? Cool. Yeah, so this is Etherpad. It's a collaborative text editor for the web. So if you see anything that looks like this, where text is color-coded in different colors, it's got chat, it's real-time. I made this in 2007 with my friend. Started a company around it, sold the company to Google, ended up working on Google Wave and Google App Engine, which were both kind of like cutting edge projects in web app development. Now I work at Meteor. What is Meteor? Meteor is an open source project under the MIT license. It's a full stack web framework, and it's also a VC-backed company of about 15 people and counting called Meteor Development Group. Meteor Vision is to help you build great apps. So you being the application developers, web designers. The bar for web apps has gone way up these days. We have Facebook and Google and Twitter and GitHub producing these like really high production value apps. They're real time, they're fast, they're interactive. So the Meteor Vision at a technical level includes having end-to-end reactivity, meaning that you have real-time updates that go all the way from your database to the web browser, all the way from your data models to your templates. And the full stack is event-driven, which is just part of the whole reactive story that's really catching on these days, which is that you need to have events everywhere so that when something happens, the effects ripple throughout the system and you don't have any situations where something's updating every 30 seconds or it updates when you press refresh. And those things really just kind of slow down the system. You want it to be cloud deployed and horizontally scalable. Ideally, you just write your app and the scaling's taken care of for you. There's more and more products on the market that do this in different forms. You've got EC2 for as many machines as you want to provision. You've got different scalable databases. It's not really a solved problem in that you still have to do a lot of work around it. And Meteor helps a lot with that. That's not what I'm going to be talking about mainly today, so I won't go into that too much. But part of what Meteor does is it helps you deploy your app as well. And you want your app to have a rich, modern user interface. So I want to show you an app built with Meteor just as an example of this. This is an app I really love called PinTask. It's kind of like Trello or different task organizers you might have seen. But it's really cool because you can rearrange these cards. You can, drag these around. This is all done with Meteor. So it updates in real time. And it's not just updating in this window. It's also writing to a Mongo database in the cloud. And if I open another tab here, you can see that it's synchronized in real time. So whoever has this tab open, as I drag this around, it's going over the hotel Wi-Fi or network or whatever to the PinTask server, and Meteor is just making all the data updates land and everything converge for you. So to make an app like this, with any framework, Meteor or not, with whatever technologies you want to put together, there's a lot of moving parts. So here's a diagram of the moving parts in an app like this. You've got the user clicking in the bottom left. There's some application logic that decides how that changes the data model, and then that updates the DOM. The cloud is this big oval at the top. You've got more logic in there. You've got your business logic, which can only run on the server because it has to be secure. It has to be trusted. And then you have some system of databases and caches. You have APIs, which might be for authentication, might be for sending a notification email that someone just added a new task. And then somewhere else in the world, someone else's web browser updates the screen, and that involves data coming down into some sort of cache and then updating the screen. So we have stuff to do each of these parts. We have EC2, we have your data center. The cloud could be any number of things. It's just kind of like a metaphor. Your database, you might have multiple databases. Real apps might have to talk to existing legacy databases. But for a new app, it could be Mongo, it could be SQL, it could be Redis. Your application, these days, Node is popular for application logic. You have WebSockets going up and down into the cloud for your real-time streaming data, and then for the DOM, you do something with templates and jQuery, presumably. So this is true with and without Meteor, basically. The thing is, what happens on all these arrows and with these caches, there's actually like some complexity here that isn't handled by current web frameworks. So for example, what do you send up the socket when someone clicks and like changes the color of a task? What do you send down the socket on the other end? And how does that result in the user interface being updated? Right now we have server-side rendered templates usually in something like Rails or Django or Java. That helps, so you can render the HTML initially, but then when you want to go to update it, you need to use something like jQuery. And then it's kind of not really clear what to do in a world where you just always have updates coming in and you're just running jQuery all the time. And it's like, wait a minute, what about my templates? So Meteor started by asking a series of questions about these arrows. And it's only a few questions. It's basically like, how does your data update the DOM? How does it update the screen? What do you send over these WebSockets? And how does that change for APIs, if you have a mobile app and a web app, stuff like that? And also, how do you get streaming updates from your database? What if you have a SQL database, you write a Meteor app, and then you go in and manually at the SQL prompt update a row? Does that immediately update your app? It probably should. But if all the updates are driven by manual application logic, that's probably not going to happen. Whereas if it's just all done by reactive plumbing, then it just happens naturally. So why don't today's web frameworks solve the problems faced by all modern apps? Because these are problems that we all have. There do exist web frameworks that solve these problems. They tend to be inside big companies like Google and Facebook, and they tend to be proprietary. So basically, like, over the years, they have solutions to these problems, and they have teams of 100 engineers working on it. And maybe it's not even really a framework. Maybe it just works for their app. They have some way of doing it, and that's what's kind of raising the bar. But then, when you want to make an app, you're looking around at what tools you have, and what are the latest Node packages and what's in the community. And you don't really find what you're looking for. You find all these different parts. You find kind of a bucket of parts, and then you're left writing all the glue and all the boilerplate and stuff that glues it all together. So the answer to this is we're in a transition period. This kind of app is new, and we're coming out of previous eras of how you write web apps into this new era. So the tools just kind of aren't there yet. And what Meteor is doing is creating these tools now. We've been doing this for the last 2 years, so I think we've got kind of a head start on this problem. But basically, we are now landing the tools that solve these problems. So I'm going to go back in time 20 years. This is 1995. And the point I'm trying to make is that the web came from these humble beginnings. The web did not run apps. You had your apps. This is Photoshop 3.0. And it's really fancy. It has brushes and colors and palettes and stuff. And this is Netscape 1.0, showing Yahoo. And basically, it's got links and it's got text, and you can tell your web browser to fetch a text document, and you can click on a link, and you get to another URL, which gives you another text document. And this is not really an app. This is just text documents. You can also have forms. You can have images. You can have tables, in fairness. And then people learned how to put images in tables, and that people are just off and running for the next 10 years with whoa, that has potential. But it's not how we're used to writing apps, like Photoshop. Except maybe it is if you wrote mainframe apps 20 years before that. So if you're not familiar with how mainframes work, there's basically one central computer. You're over the network, you have access to it through a video terminal. And all the video terminal does is it knows how to display these screens that are like presentation screens. And they have forms, and they have text, and they take your keyboard input. And then when you want to go to a different screen, it goes to the mainframe, and it's like, all right, here's your data. Give me another screen. And that should sound pretty familiar. In fact, I pulled this image from a website called Mainframes 360. It's a current website. This isn't because people still do use mainframes. And the website says a 6 map, which is the name of the presentation language, is a GUI screen just like an internet web page. It can have a title header, display only constant fields. It can have input fields. So basically, the way we now explain a mainframe screen is to say it's basically a web page. Think of a mainframe screen like a web page. Or if you like, think of a web page as a mainframe screen. It's just something that's loaded over the network. It has forms, and then you say, okay, I filled out my forms, and you get more forms. Sort of like apps like as DMV, where you go in and you get forms, and you fill them out, and you get more forms. So even so, though, web apps were still a revolution because you can deliver apps in a new way. You don't have to install software for a web app. It's usable upon discovery, meaning like the time between when you find out about an app and when you're using the app can be basically zero. Like you click on something, you type in the name of a website, and you're like, huh, I want to check this out. And then you're there. Whether it's like Google Docs, Wikipedia, you follow a link to a Wikipedia page, and then you can be editing that page immediately. It's cross-platform, so the web just kind of provides this cross-platform web runtime. So if you don't know whether to write your app for like Mac or Windows or Linux, or you just say, oh, I'll make it a web app, and it runs everywhere. They're linkable and shareable. Like I mentioned, you can link someone right into an app. There's nothing to maintain or upgrade, so this is great in all sorts of settings like the enterprise where you don't want to deal with software upgrades. And it's collaborative, and it naturally leads to things like Wikipedia because you've got the database on the server and everybody's kind of dialing in, just like with the mainframe. Everybody is dialing into the same app. You've got this shared data model, and that's really cool. That's a new thing with web applications. So Hotmail in 1996, this was a revolutionary web application. And the revolutionary thing about it was HTML. As you can see from this logo, the letters H, T, M, and L were made extra big to kind of say like Hotmail is HTML. This is a really bad logo. It was around for a year before they killed it and replaced it with a better one. But at the time, the fact that you could access your email from anywhere was a new thing. Like you could go into an internet cafe, while you're vacationing in Thailand and pull up your email, and that was not something you could do previously. You had, your Outlook client, and it was all configured. So this is an early example of the potential of web apps. Where was JavaScript in all this? Hotmail was not a JavaScript app. It was a web app. The problem is JavaScript was too slow. The execution engines were really slow. Modifying the DOM was slow. So if you started like moving stuff around, elements in the DOM, you start to have, lags and repaints and just kind of run out of time. Internet connections were slow, so you couldn't download like 100K of JavaScript. You could barely download 20K of JavaScript. And by the way, it wasn't gzipped. Browsers supported gzip starting in around 2000. So these are uncompressed numbers. Poor cross-browser compatibility. It was actually pretty hard to write JavaScript for like Internet Explorer and Netscape. There's still a few gotchas, but it's gotten a lot easier. And JavaScript wasn't always available. People had JavaScript turned off. There was kind of an ethos of like, your site should work with or without JavaScript. People are worried about the security consequences of having a scripting language in the browser. So, basically you didn't have penetration of JavaScript. You could say, oh, maybe 80% of my users have JavaScript or something. Now it's just kind of expected, and that's really great for app developers. So I'm calling 2005 the dawn of the fancy client. And this is when people start doing new stuff in the browser besides loading just a new screen, like from a mainframe. The term AJAX was coined in 2005. jQuery was first invented. Internet Explorer 6 at the time was this huge boon for app developers because it had things like AJAX, basically. And we had cross-browser JavaScript starting to become more feasible. So one of the big things jQuery does is it lets you write your JavaScript once and run it on any browser. And that was a really big deal. Dynamic HTML is just kind of a buzzword for the idea that your HTML, it's interactive, it's updating live. It was first used as a marketing term for Internet Explorer 4, interestingly. They said, now, Internet Explorer 4 with dynamic HTML. And that meant things like the DOM, basically. Now we have a DOM. Gmail got AJAX in this year. And that's really what kind of put AJAX on the map. People said, wow, when I click on a message in my inbox, it doesn't reload the whole page. It just fetches new HTML, and it only reloads part of the page. And that's really great, because I'm not pulling down all the nav bars and everything every time I click on something. So, just kind of trying to put this, this is kind of where we came from. So yeah, only update part of the page. There's a sense that you can do anything in the browser. And this is when Google Docs came out. They're like, all right, now we can do a word processor in the browser. Now we can do spreadsheets in the browser. Let's make all this stuff. Lots of cool widgets. And the idea that you don't download HTML, maybe you don't even download a partial page, you download JSON, or you download XML at the time. You download data over the network. So you had widgets like, chat widgets and stock tickers, image galleries that never reloaded the page. They just pulled in new image thumbnails as you navigated. So you'd only be fetching data over the network and not new pages. And Etherpad was kind of written at the height of this. I'm pretty proud of how interactive it was, but basically it was just pushing the limits of AJAX in real time and doing things locally on the client and then synchronizing over the network as well. Also, since then, browsers have just been getting steadily more awesome. JavaScript engines are super fast. CSS is hardware accelerated. You have hardware accelerated graphics, and not just with OpenGL, but with everything. Everything you do is like super snappy. It's even super snappy on phones, which have graphics hardware and JavaScript compilers. JavaScript support and tooling is a lot better. The language is getting better. We kind of know how to write JavaScript better. So the user interface possibilities are limited. You can do anything, basically. You can put anything on the screen, but can you make an app with it? That's really the real question. You can make a rotating cube. You can make a Rubik's Cube, Google Doodle, but can you make a full app? And the problem there is that AJAX and jQuery lead to a lot of spaghetti code. If you just keep manually writing, okay, now fetch this data, now go update like the class on that DOM element, and now like fetch this other data, that really doesn't lead to a scalable architecture for building apps. And it's hard because the server traditionally has all your data. The server has a database. It has your business logic. It has your HTML templates. So what exactly is the client supposed to do besides maybe like a little bit of animation or a little bit of sugar on top of the existing experience? So I'm announcing the dawn of the thick client. This is already started, but really like it's still on the ramp up. Basically, we're still starting to see what's possible when you take the browser seriously as an application platform, where you have data, logic, and presentation in the browser, able to update the screen without a network trip. So like losing this idea from the mainframe that like you have to go over the network just to get what to display next. And we're building larger JavaScript applications, which takes a real investment in the JavaScript language, good patterns for modularity, stuff like that. Real-time collaboration is a big deal because like the web is just sort of naturally collaborative. So if you take that and combine it with real apps, you get something entirely new. Like Photoshop was not written in an era where it was expected you could link someone into a Photoshop document or like a Word document, or that it's just seamlessly backed up to the cloud and someone else can just drop into your document. Like that doesn't happen. We've got these two different worlds right now. We've got the web where UI is simple and your data is in the cloud, and we've got the desktop where UI can be really like rich and complex, but your data is all like siloed. And what's happening now is those are coming together. And I think that's where you need something like Blaze to kind of make this story work. Okay, so I'm now entering the Blaze portion of the talk. The big deal with Blaze is you just write templates, and they update automatically. I have a handlebars template on the left here, and a Jade template on the right. And these are the kinds of templating languages people are using. The thing is that right now, the way you use a templating language, and this includes Rails templating, PHP, is the purpose of the template language is to generate HTML on the server, and that's sent down to the client. And after that, like, who knows what happens? Like, you run some jQuery, but you never go back to the template. We thought, wouldn't it be great if basically you wrote your templates, and then they just kind of kept updating? So it changes what the template means, so that now any of this data you access in your template could update at any time, and it'll refresh the screen. So I'm gonna. This is much easier to show with an actual demo. going to open up some code for you guys here. Okay. Yes. Thank you. Conference goer. It's actually my coworker, Avi. Yeah, I didn't get set up with this resolution in advance, so here we go. Okay. So people generally use Blaze as part of Meteor up till now. But for this demo, I want to show you just using Blaze by itself. There's nothing fancy going on here in terms of like, the Meteor magic I talked about earlier. But there's a lot of Blaze magic in the user interface I'm going to show you. So I'm just opening an HTML file. This is the entire contents of the file. It's got some inline style up here. And then I define a template, and I use a script tag to just kind of like drop the template right into the page. I actually don't think this is a good pattern for a production app. You don't want to like put all your templates in script tags and serve them with the page. What you really want is to compile them ahead of time and not just plop all of them into the page like this. The reason I did this is because it's easier to play around for a demo, for a talk, to just have everything in one file. And it's really easy to just drop into a template this way. So I've got a template. I include Blaze.js. And then in the script here, I set up a state variable, and I set up a helper. So the state for this app is just a string called your name. It's a blaze.var. So if I say, make this really big. Okay, so blaze.var is just kind of like something that holds a value. I can create one right now. X is blaze.var1. If I set it to 2, and then I get it, then it says 2. If I set it to 3, and get it, it says 3. You get the idea. But if I set your name to something else, like let's set your name to Steve, then bam, the page just seemed to automatically update. Like, that's useful. So it's worth asking sort of like, what happened there, because to all appearances, what happened is I specified this template. I invoked Blaze, which somehow took in this template and rendered it. And then when it rendered it, it calculated what the name should be. It put this into the DOM, and then it was done. So the question is, how does it then know to come back and revisit this template later? How does it know the data has changed? And also, how did it update the screen? So you might think like, okay, here's what it did. It said, whenever anything changes, I'm just going to recalculate this template and put it on the screen. Well, we can test that by saying like, what if I select some text? Like if I select this hello and I change Steve to David. Like, oh, it didn't disturb that. If I take this bold tag here and I add a style like background yellow, I can still change it. So it's obviously not re-rendering the whole template. In fact, it's not even going back and like, parsing this b tag again or like creating this b tag again. It's not doing anything except connecting up this template tag directly to a space in the DOM. And that's really the exciting and powerful and unique thing Blaze does, is it gives you templates that are interpreted in such a way that you get these very fine-grained bindings, these very fine-grained just kind of automatic updates between your data and different parts of the DOM. And I didn't just have to say, take this var and take this text node and hook them up. That would be sort of like a really basic binding pattern, because I wrote a function here. Name is a function, and this could be anything. This could, this could just always return, Boris, and not go there at all. And now it'll say hello, Boris. Or it could access a whole bunch of different, vars. It could access the database. So that raises the question of how does it know to update? How does it know I access this var? Because in other frameworks, I'd have to express that to the framework somehow. I'd have to say, you might think, oh, blaze.var, that's sort of like an observable. like you might have seen in Knockout. Well, there's no call to observe. I never say, something like, whenever this var changes, update the screen. All I do is access it. So somehow the fact that I'm accessing this var is leading Blaze to know that when that changes, it needs to go back in and change that part of the DOM.
Hey, I'm sorry, but did you refresh the page, or why did the yellow background go away?
Yeah, I pressed Command R. That's why the yellow background went away. Yeah. So we have fine-grained updates, which meaning that the smallest possible DOM change happens when the data changes. Control structures like if and each are what make larger scale structural changes. And let me just make this a little more interesting. Do some live coding here. So suppose instead, this might require small knowledge of handlebars, but basically one of the constructs in handlebars is if I use with, I can set the current context for any data lookups that happen. So I'm going to change my data model to say, I have more data than just someone's name. In fact, I have this whole object, and name is just one of the properties. So I'm going to change my helper greeting to return yourgreeting.get. And then the way handlebars works is that accessing name here now means access the name property of the current context. So let's see if I got that right. This is hello, David. If I were to set your greeting to something else like name Steve, it'll change. So that's not too different from before. With has another useful property, which is that if its argument is null, it doesn't render its content. So that's another thing I get now. I could also have an attribute here like style equals background color. And perhaps I want to get that from the color property of the greeting object. So now name is David, color is green. I can set this object to something different, like color yellow. But here's something cool. If I have some of this text selected and I just change the color to something different, I don't lose my text. So it's really somehow what it got out of that change was all you should do is set the style attribute on this div to something different. So that's just an example of how we can hook up data to the DOM in a very fine-grained way. And basically, Blaze has to really fully understand this template. It has to know that these are HTML elements, and it has to parse the template. And I think that's actually why this isn't done in more frameworks, because parsing templates is hard, and mucking around with the internals of template engines. What you see in some other frameworks is Angular avoids the problem by saying, oh, templates are just a case of HTML. And React says basically templates are a case of JavaScript. So they basically just kind of throw out the template language and say, maybe all we ever needed was HTML with some extra attributes. Or maybe all we ever needed was JavaScript. And what we did was we looked at what people are already doing, because we're trying to work on just the overall experience and those green arrows I showed earlier about how things are glued together. We're not trying to force a new way of templating on anyone. We're just trying to make it good, basically. So that's kind of where we're coming from on using templates. So how does this work? How does the data get hooked up? This is very interesting. Sorry. OK, here we go. It's basically thanks to reactive programming. The question is, how do we write code that reacts when data changes? There are different patterns for writing code that does something when data changes. You could poll and diff. You could say every 30 seconds, I'm going to check, see if something changed. Maybe diff the data just to make sure I don't do too many extra changes. You could register for notifications, also called callbacks or event listeners. You can have data bindings where you say, like, take this and wire them up. But what allows the kind of experience I just showed you is reactive programming. And reactive programming is different because it says you just write code assuming that values may change. You don't express the procedural logic of, like, listen to this and change that. If you want to say, add these two numbers, you just say a plus b. And that doesn't mean add them now. It means add them forever. It means, kind of like when you write a spreadsheet and you say equals a1 plus b1. You're just declaring what you want. You're not saying, like, run this code, and then later, if like a1 or b1 change, you have to go and like run the code again. It just gets run for you because you specify what to do, not how to do it. And Meteor takes this and puts it in the land of JavaScript programming because you just write the templates and the JavaScript code you might write anyway, and Blaze makes it a reactive program. You don't need to observe the vars. You don't need to declare your dependencies. Basically, kind of the other like remaining pattern, if you don't have this system, is what Ember does, which is you tell it that your helpers depend on certain vars. So you would tell it that the name helper depends on the name var, and then it says, OK, I'll do that updating. With transparent reactivity, which is what we do, you don't have to do that. You just access the data, and everything just happens for you. The way we do this is with a little library we wrote called deps for transparent dependency tracking. It's only about 1K of code on the network. It automatically associates computations, like calculating that name template tag, with data sources like the blaze.var. It's simple, but it's very powerful. So in this case, the computation is calculate the new value for that template tag and go put it in that particular text node in the DOM. When it goes to access the blaze.var, that immediately is a queue for a dependency, the dependency system to establish this link. So whenever you access a data source from a computation, meaning while you're running the computation, that automatically creates this association in the depth system. And then when the var changes, that triggers the computation, and the computation says, OK, I'm going to run again. I'm going to calculate the value of name, and then I'm going to update the DOM. And there's some details to make that actually work that I don't have time to go into, but basically you get this really flexible system where it supports a really wide variety of kind of data sources. It leads to really understandable code because, like, you don't have to deal with depths directly when you use Blaze, but if you want to, you can peek in there and say, oh, I see, it's just like a bunch of auto runs that are nested in a particular way. It's a bunch of computations that automatically run when they're triggered by a data change. So an interesting question is, how do we achieve this kind of like deep template experience I've been talking about and have a pluggable template syntax? So I showed a handlebars template and a Jade template earlier. Blaze is the first reactive user interface system to support arbitrary template languages. So not just reactive templates, but also, we didn't just work really, really hard on this like handlebars template compiler. We made the general system for all reactive templates. And the way that works is that Blaze doesn't compile templates. It's an API that's targeted by template compilers. It's kind of like the VM for reactive DOM updates. Templates are just reactive functions that call the Blaze API. And you can even write your own reactive templates in pure JavaScript if you want to. But I think a much better experience is when you get to use one of these template languages that people have been working on that's really been tuned for the kinds of apps people need to write, and the kinds of HTML. Basically, templates are what you want to have in your text buffer. They're what you want to edit. They're nice to work with. So I'm going to show you a demo of the Blaze template compiler. This is so this is just a little like rig where I can type in a template like div hello, and below is the compiled template code. So this is basically the function that gets linked into your app when you have a template. So we don't say like, oh, the browser should like parse this. We just as part of putting your app together, when you build your app. You might be using CoffeeScript, so you have a CoffeeScript compiler to JavaScript. You also have a template compiler, and it also produces JavaScript. You can go in and say, okay, see what's happening there. What it's doing right now is I don't have any template tags in here, so it's just, as an optimization, it's saying, okay, just like here's a string of HTML to splat into the page. If I were to get a little fancier and say hello name, now I get a little data structure here that's sort of like a little DOM language that goes into the Blaze API. So it's saying make an HTML.div object representing the fact that we have a div, the string hello, a b tag, and then this function, which is kind of like a reactive region in the DOM. And Blaze takes this return value, and it walks through and says, oh, okay, there's a function here. I'm going to make that a live updating range of the DOM. I'm going to use deps and make that automatically reactive in a transparent way. What else can I show here? I could do an if condition. You get nice error messages, by the way. I made sure of that. Now it gets a little complicated. We're still working on this API format. But basically, you can see that it's invoking a UI.if, and it's looking up these particular names in the current context of the template. The cool thing is that I can switch over to Jade mode, and I can say, let me dust off my Jade brain here. I can say, div hello, and then a b tag with world, or a b tag with name, and it just produces exactly the same code, meaning it's completely agnostic as to how you're writing your templates, and that's really powerful because it kind of like one of the things people worry about with frameworks is, oh, I'm inheriting all these opinions from someone else. I can't use the tools I like. And one of the things Meteor tries to do is say, no, you can still do things the way you want to do things. We're just going to take a lot off your plate, which in this case is the jQuery code that you'd have to write. I've written this code. I think a lot of us have written this code where you take jQuery and you go in and you actually find that text node or you find that div and you update it. And that's the part that's just completely absent from a system like this. And I'll take you briefly to the Blaze landing page. We have some great demos of Blaze on here. And we created this page like just this week, so but one of the things that's really cool is you can just you can use SVG as well. So here's a clock. It's updating every second. And the template is just this SVG code where occasionally you call out to a helper to get the position for the lines of the clock. You can also write SVG in Jade. So if I click the Jade tab, and you can imagine it's a lot of fun to write code in this style. You can, you've got SVG, you've got Jade, and then you don't have to worry about how it updates. You can just type it in. If I open this in CodePen, come on, network. So CodePen is a great way to try Blaze because it updates as you type. So it doesn't seem to be loading. There it is. So I said, oh, okay, I want these ticks to be longer. I'm going to change this number to something different. And then bam, it's different. So this combines all kinds of reactivity. It's like the development process of immediately seeing the change you made. The fact that I can change anything about this and I don't have to change as much code in as many places. So other features I may or may not have mentioned. Event map, so there's a system for just declaring what events you want to happen where. It's really easy to use. I didn't even get to show nested templates, which obviously in any template language you package you have multiple templates, so you divide your HTML into templates and they call each other. Template lifecycle callbacks, so like whenever this template's rendered, go in and do this extra thing with jQuery. You can totally, I think this is something that's also unlike other frameworks like maybe React, is that we don't say we assume we own the whole DOM. We don't say, well, everything's going to happen through Meteor. No one's ever going to use jQuery ever again, so like, we don't make that work. No, like because the DOM updates are fine-grained, a variety of things like that, often jQuery will just work, and if not, the integration is pretty simple. And in fact, like our package system means that someone just does the integration once, and everybody else gets to use it. This is our package system, which is itself a Meteor app. So if I want to search for jQuery packages, these are various community contributed jQuery packages for Meteor. So you can see there's definitely like a lot going on there. It's because we have a community of users who are writing real apps, like that one I showed you at the beginning. People need their jQuery plugins right now. Like they do a lot of cool stuff. So and you can like do stuff like use Blaze inside a Google Map. You can like mix and match stuff. So it's really well suited to that. Some of the kind of Blaze technical specs. It's about the size of jQuery. It's not a huge download. We made sure it was very like kind of self-contained, doesn't have a lot of dependencies. It supports Internet Explorer 8 Plus, and I don't even have to say like all other modern browsers. All versions of other browsers that people still use, and i8 Plus. It uses jQuery if present, and jQuery is basically used for Internet Explorer 8 support because there's a lot of legacy stuff there. And a lot of people just want jQuery anyway. They want to run bits of jQuery. They want the jQuery selector engine. If you are only targeting modern browsers and you don't want the extra code size of jQuery, the dependency is pretty narrow. It's pretty easy to just have a shim for modern browsers, and then you don't even need jQuery. You just need Blaze. Include Blaze.js. And it's now available as a standalone build. It's still, we kind of have just broken it off, so we're still working on the docs and stuff like that. But the idea is, use Blaze, basically. Like, we don't want there to be any reason for people not to use Blaze, because it's just too good. Coming soon, these are things that, like, the kind of things where it's like, oh, of course it has to have that. We can't even, like, ship it without that. But then you end up shipping it, and you say, okay, but, like, this is what's next. We need modular components. You need to be able to break your app into components that each have their own reactive state. That's just like part of any good framework. Animation hooks. Maybe you want that if to be animated so that when things come and go, you just say, oh, by the way, like make that fade when it comes on the screen or leaves the screen. Inline JavaScript expressions, basically more ways to put JavaScript into your templates so you don't have to write as many helpers. And server-side rendering, one of the design decisions in Blaze since the very beginning is it doesn't just generate DOM. That representation I showed you where it said HTML.div, blah, 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 that can be used to generate HTML. So on the server, you can generate your templates if you want. And it works on the server, it works on the browser. It doesn't require the browser, basically. And there's lots more coming. Like, basically anything that app developers need to do, we want to add as a feature. And if we don't, they will add it themselves, or they will, start writing packages to do it. It's a very exciting time. So join the revolution. Basically, you should be using Blaze or something like it. You should be, writing apps this way, because this is a really nice way to do it. And, we're entering this new era where apps are going to be written this way. So you can find us on the web at meteor.github.io/Blaze. You can try Blaze by just trying out Meteor, and if the Meteor backend stuff doesn't work for you, you can just take your Blaze templates and use them with your own backend, or you can just try using Blaze.js. If you want to learn more, if you want to get announcements as we develop this, definitely join our Google group, which is just called Blaze.js, not .js, Blaze.js. Thank you.